Welcome to This Explainer. Today, we're tracking the falling dominoes of climate change, moving from those invisible atmospheric shifts right down to the realities on the ground. We're going to look at the hard data, trace the chain reactions, and uncover exactly how a shifting global climate impacts everything from the deepest oceans to our own backyards.
Okay, let's dive into our roadmap for today. We're going to cover the drivers of climate change, peek inside the greenhouse effect, look at Earth's changing physical landscape, the ecological ripple effect, the human and social cost, and finally, climate change in India. Let's get right into it.
Section 1. The drivers of climate change. Let's set the baseline and understand those initial forces that push the very first domino in our climate system.
So there's this really stark dichotomy between the forces shaping our climate. On the natural side, you've got things like variations in solar radiation or volcanic eruptions. Those eruptions can actually emit aerosols that block sunlight, causing a temporary cooling effect for maybe 1 or 2 years. But then we have anthropogenic, or human-caused drivers. Things like massive greenhouse gas emissions, clearing out forests, and large-scale livestock farming. These create a totally different effect. They cause a persistent, compounding warming that just continuously builds on itself.
Section 2. Inside the greenhouse effect. So how do these human-made drivers actually go about trapping heat and altering our atmosphere?
Well, we all kind of know the basic mechanics, right? Solar radiation hits the Earth, and the Earth re-emits it as infrared energy. Naturally, our greenhouse gases trap just enough of this to keep the planet nice and hospitable. But human activities are aggressively thickening this atmospheric blanket. We're pumping out so much excess gas that the infrared radiation literally can't escape back into space, trapping all that extra heat right here with us.
When we look at where this blanket actually comes from, the breakdown is pretty revealing. Electricity and heat generation lead the pack at 25%, and that's closely followed by agriculture and land use at 20.4%. I mean, think about that. Just the power we use and the food we grow make up nearly half of all global greenhouse gas emissions. Industry and transportation are right behind them.
But, it's not just carbon dioxide we need to worry about. While CO2 sets our baseline, look at the bottom of the list, sulfur hexafluoride. Used mostly in electronics, this industrial gas has a staggering global warming potential of 23,900. No, really, 1 ton of this gas traps 23,900 times more heat than a ton of CO2, and it lingers in the atmosphere for over 3 millennia. It's not just about the volume of emissions, it's about this extreme chemical potency.
Section 3. Earth's changing physical landscape. Once all that heat gets trapped, the physical Earth begins to react, toppling the next set of dominoes.
When we think of global warming, we usually picture hot air. But it is absolutely crucial to realize that over 90% of this accumulated energy isn't heating the air at all. Instead, the Earth's oceans are acting like this massive planetary sponge, soaking up more than 90% of the excess heat trapped since the 1970s. This invisible absorption is fundamentally, entirely altering the marine environment.
Meanwhile, way up high in the stratosphere, human-made CFCs are drifting upward. Up there, intense UV rays strip a highly reactive chlorine atom away from the CFC molecule, and that chlorine then ruthlessly tears apart our protective ozone layer. And what's really terrifying is how the environment supercharges this whole process. During the harsh Antarctic winter, polar stratospheric clouds form, providing a physical surface that actually accelerates this chemical breakdown.
Section 4. The ecological ripple effect. With the atmosphere altered and the oceans warming up, entire biological and ecological systems begin to warp.
Remember our ocean sponge? Well, it is suffering a severe triple threat from soaking up all that heat and carbon. First off, as water warms, it physically expands, driving an accelerated sea level rise that literally drowns coastal wetlands. Second, warmer water holds less oxygen. This leads to expanding oxygen minimum zones, basically vast swaths of the ocean where marine life simply suffocates. Throw in larger, more frequent toxic algae blooms that make wildlife sick, and you've got an ecosystem under extreme duress. But wait, there's a third threat happening at a microscopic chemical level.
As the ocean absorbs a massive chunk of our CO2 emissions, it creates carbonic acid. Now, this acidification is essentially a chemical theft. The acid reacts with and steals carbonate ions right out of the water. Why does that matter? Because those carbonate ions are the exact building blocks that marine organisms, like corals, clams, and oysters, rely on to build and maintain their shells.
We are literally robbing vital marine life of the very architecture they need to survive.
Section 5. The human and social cost. Let's see how this builds into profound impacts on human society and our daily lives.
All this physical and ecological data directly translates to human suffering. As the environment degrades, we see a massive domino effect on our civilization. Extreme heat and severe droughts diminish soil fertility, which directly threatens global food security. Rising temperatures lead to increased heat-related illnesses and a very real loss of physical work capacity in hotter regions. Furthermore, warmer climates allow vector-borne diseases like malaria and dengue to spread into entirely new territories. Add to this the terrifying potential for civil conflict as communities fight over dwindling freshwater resources, and you quickly realize climate change is a direct threat to global security.
And this brings up a critical perspective that often gets overlooked. Climate change isn't just an agricultural or medical issue, it's a deep social issue. It prompts us to ask, how does environmental stress uniquely impact gender dynamics and human security at the household level?
Well, the data reveals a pretty harsh reality. Climate stress actively exacerbates existing power dynamics. When water becomes scarce, the time required to fetch it increases. Historically, this disproportionately exposes women to an increased risk of gender-based violence. Severe droughts force male family members to migrate further for work or grazing, which drastically increases the household and agricultural burden on the women left behind. Meanwhile, for men, faltering rural livelihoods and economic desperation can become a major contributing factor in decisions to join armed or illicit groups. Basically, environmental breakdown actively frays the social fabric. To truly grasp these cascading, localized effects, let's look at a specific regional hook. Since 1901, the average temperature in India has risen by approximately 0.7 degrees Celsius. Now, that might sound like a tiny fraction of a number, but let's look at what that fraction of a degree is actually doing on the ground.
Section 6. Climate Change in India. The Ministry of Earth Sciences gives us a clear lens to see how global warming completely alters local meteorology on the Indian subcontinent.
So the surface temperature of the tropical Indian Ocean has risen by a full degree. This brilliantly illustrates the paradox of a changing climate. Over the last several decades, overall summer monsoon rainfall has actually declined by 6%. Yet, simultaneously, the frequency of sudden, violent heavy rain and flooding events has spiked by 75%. We're getting less steady rain, but when it does rain, it's devastatingly intense. Meanwhile, the drought-affected areas are just creeping upward, decade by decade, and Himalayan glaciers are experiencing significant retreat.
The crucial point here is that no system is isolated. I'll leave you with this staggering projection from the Hindu Kush Himalaya region, an area often called the third pole because of its massive ice reserves. Even if we achieve our most optimistic, ambitious goals and cap global temperature rise at 1.5 degrees, we are still projected to lose more than a third of these glaciers by the end of the century. If we stand to lose this much ice under our absolute best-case scenarios, permanently altering the water supply for millions, how interconnected and fragile are the global systems we rely on every single day? So what does this all mean for us? Think about that as you consider your role in our changing climate.